Assalamualaikum and a very good day to everyone. Today we will be presenting about electromagnetic issues in automotive vehicles. First and foremost, electromagnetic is the combination of electric field and magnetic field. It is what that triggers the usage of wireless technology. Wireless technology is developed to neglect the usage of cables either for data transmission or electrical transmission. It is a simple yet important feature for technology users nowadays. It helps people doing their job without any complications anymore. Electromagnetic also changes the world in every aspect it could encounter. For example, our phone charger is usually connected with a cable, but nowadays wireless chargers are available for many kinds of phones. Device using electromagnetic field also grows exponentially from time. We can see in the old days, electromagnetic field is used widely on a home-based radio technology. But nowadays, we can see from the usage of huge electrical transmission using transformer. Here's a question for you. Have you ever heard your car radio makes an unwanted disturbing sound? Probably yes. Let me explain it to you why it happened. As more wireless devices come into market, these devices tend to disturb with one and another. These devices need to operate at its own very specific signal. This creates a huge and a lot of signal being used at one time. These signals then produce a disturbance called the electromagnetic interference. This interference is widely known and yet to be solved. For example, when you have your phone and other devices in the car, your car radio tend to make the disturbing sound, which is caused by the disturbance from your phone's electromagnetic field and the car radio's electromagnetic field. Electromagnetic interference (EMI) is also known as radio frequency interference. It is the disruption of electronic device operation caused by unwanted signals, as I explained before. There are two main sources of EMI. External EMI. It is developed from other devices that are near to the targeted device, while internal EMI is developed from the processes happening inside of the device itself. Meaning here, external EMI is caused from other devices, while internal EMI is caused within the device itself. We move on to EMI types. There are two major types of EMI. Firstly is natural EMI. Natural EMI is an uncontrolled event of nature. This can be seen from lightning, thunderstorm, and atmospheric noises. While man-made EMI is caused by electronic devices that possess switching system or electrical system that undergoes change in large current. This can be seen when power surge happen or when devices near to us tend to use power switches. Transmission of EMI. EMI is transmitted through two major types. It is conduction and radiation. Radiated EMI is transmitted by the electromagnetic fields and received by the antenna effect of other equipment. Radiation is widely used and mostly common in every wireless devices in the market. Coupling. Capacitive coupling and magnetic coupling is available through conduction. Capacitive is basically the use of capacitor concept. Capacitive coupling occurs when a change of voltage from the source capacitively transfers a charge to the victim circuitry. It means the source of EMI transfer a charge to the victim devices through voltage change. Magnetic coupling exists when a varying magnetic field exists between the source and the victim circuitry. This results in increase of current in the victim circuitry and transfer signal from the source to victim.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz Idham Ramli. First of all, I would like to say thank you to Muhammad Hafizi. Okay, now let's proceed with background of study. Carl Friedrich Benz, or can be called as Carl Benz, was born on 25 November 1844. He is a German engine designer and automotive engineer. In 1879, Carl Benz was granted a patent for his engine, which have been designed in 1878. Many of his other inventions made the use of the internal combustion engine feasible for powering a vehicle. Carl Benz began promotion of the vehicle on 3 July 1886, and about 25 Benz vehicles were sold between 1888 and 1893. When his first four-wheel was introduced along with a cheaper model, this car also was powered with four-stroke engine by using his own design. Due to development, most of the system become more complex compared to the old system technology in terms of vehicle industry growth. Advanced technology have been used to expand the market of modern cars which fulfill the society demand. The introduction of renewable energy has brought consciousness to many industries, including automotive, to create a healthier product for the environment. In case of automotive industry, hybrid technology is widely used to make cars work on electricity, discarding the element of harmful gas emission. Tesla, one of automotive company that create electrical cars since July 2003, and now become one of the biggest car manufacturer in the world. Tesla is an American electrical vehicle and clean engineer company based in Palo Alto, California. The company is specialized in electrical vehicle manufacturing, battery energy storage that using source from renewable energy such as sun and so on. Tesla Motor was founded in July 2003 by engineer Martin Eberhard and Mark Chapman. The company name is a tribute to inventor and electrical engineer that called as Nikola Tesla. Tesla launched its initial public offering IPO in 2010. Okay, before that, initial public offering IPO is a type of public offering in which shares of a company are sold to institutional investor and usually also retail investor. An IPO is underwritten by one or more investment bank who also arrange for the share to be listed on one or more stock exchange. In 2010, the price of stock is around $17 for Tesla. Now in May 2020, the stock price of the company has skyrocketed to $816 per share, with a decrease about 1.3%, around negative 10.72, due to pandemic crisis of COVID-19. This proves that the investor believe in electrical car will get a high demand to become leader of the market in the future. Due to development of electric modern car, this will lead to electromagnetic interference, or can be known as EMI, because the increasing of electronic components that have been used in electric car. Electromagnetic interference is a disruption of operation of an electronic device when it is in vicinity of an electronic field in the radio frequency spectrum that is caused by another device. There are many sources of EMI in automobiles, such as electric motor, that are used to operate many devices such as windshield wiper, heater and conditioning fan, rotating warning light, and so on, which is source of electromagnetic interference in automobile. There are many sources of electromagnetic interference in automobile, but we know we are focusing on two main parts, which are ignition system and unshielded cable. Before we proceed with the causes that affect ignition system, better we know how the ignition system works. In the ignition system of car consists of several components, which is battery, ignition switch, ignition coil, contact breaker, cam, condenser, distribution that having rotor and stator, and few of spark plug. The battery is the source of electrical power in automobile that produce 12 volt. When the ignition switch is turned on, current flow from the battery to the ignition coil. In the ignition coil, current flow through the primary winding of the ignition coil, where one end is connected to the contact breaker. A cam, which is connected directly to camshaft, open and close the contact breaker point according to the number of engine. To make sure that you understanding about the contact breaker, for example, if car with 4 engine cylinder, it will open and close the contact breaker for 4 times. If the car is 6 engine cylinder, it will open and close contact breaker for 6 times. A condenser absorbs back EMF from the magnetic field, thereby increasing the life of contact point by reducing burning of the point. When the cam loop push the contact breaker switch, the contact break point open, which causes the current from primary winding circuit to break. Due to break circuit, EMF is induced in the secondary winding, having more number of turns than primary, which increase the battery 12 volt to 22,000 volt. The high voltage produced in the secondary winding is transferred to the distributor via high tension cable. A rotor inside distributor rotates according to the ignition timing. When the rotor comes exactly in from the distributor point, the voltage jump due to the air gap from the rotor to the distributor point. High voltage is then transferred from the distributor to the spark plug terminal via a high tension cable. A voltage difference is generated between the central electrode and ground electrode in a spark plug. When the voltage exceeds the dielectric strength of the gas between this electrode, central electrode and ground electrode, the gas are ionized. Due to ionization, gas become a conductor and allow the current to flow through the gap, and spark is finally produced. Okay, let's proceed to another point. This picture shows a basic inductive discharging ignition system that was used for a decade. The system consists of a low voltage DC supply, the battery, a high voltage generator, the coil, and the distributor breakpoint, a switching mechanism to supply voltage of the proper spark plug, the distributor, is the distributor. and spark plug provides spark to a cylinder of the engine. Because of the high voltage, the opening and closing of the various points and the firing of the spark plug, this system generate radio frequency interference over a broad frequency range. This rise time of these high voltage pulse are usually only a few nanoseconds, which result in a broad spectrum of frequency. To make sure that you understanding what is spectrum of frequency, spectrum can be known as a road network, while the frequency can be known as moving transportation. For example, if the lorry are using the right lane or of the car, this will lead to the jam. In specific, can be said as interference. Basically, there are three events that occur during the firing of each plug that causes the generation of electromagnetic interference. These are the gap between the distributor and rotor-stator breakdown here, rotor and stator breakdown, extending the high voltage to the spark plug, the air gap of the spark plug breakdown here, the air gap of the spark plug breakdown and the plug fire, and the distributor breakpoint close to pass current through the primary winding of the high voltage coil. The next point is unshielded cable. Based on the research, according to Alakula, said that the space in a car often limited. It is not usually that the distance between the power electronic converter and the electrical load is fairly long. In order to reduce weight, size and cost, the cable between converter and the load are commonly unshielded. The cable from the converter to the load are usually located with some space between cable and the chassis, which work as a ground plane. Between the ground plane and the cable, there is a parasitic capacitance. To make sure that you understanding what is parasitic capacitance. Parasitic capacitance or stray capacitance is an unavoidable and usually unwanted capacitance that exists between the part of an electronic component or circuit simply because of their proximity to each other. This capacitance creates a closed current loop for modulation harmonic in the cable and the ground plane. The main characteristic which define an electromagnetic field is its frequency and wavelength. In this system, the long unshielded cable then work as antenna, especially in the higher frequency area where the length of the cable is close to the wavelength. To make sure that you are understanding, a simple analogy should help to illustrate the concept. For example, tie a long rope to a door handle and keep hold of the free end. Moving it up and down slowly will generate a single big wave. More rapid motion will generate a whole series of small waves. The length of the rod remains constant. Therefore, the more wave you generate will become a higher frequency. The smaller will be the distance between them, shorter the wavelength. This will create radiated electromagnetic emission that could be heard on the AM band on the radio.
For this topic, we targeted an automobile company in Malaysia that is established in 1992. It is known as Perodua. Perodua is a partnership company with Daihatsu Motor Company. It is also located in Sungai Chor, Rawang on a 522-acre site which comprises corporate building, 2 manufacturing building, research and development center with test track and other buildings. It is also known as the largest car manufacturer in Malaysia, which sold their cars currently to more than 15 other countries. Perodua has also sold over 3.2 million cars. 650,000 of the cars sold is the energy efficient vehicle, EEV. but some of the models stopped produced due to complaints caused by power window, radio system, and engine breakdown problem. Therefore, the solution for EMI has not been fully implemented yet within Produa's internal model.
Alright, for the discussion, we're gonna discuss about how to prevent electromagnetic interference in car. First is by shielding the cable. Shielding set boundaries for radiated engine energy through reflection or absorption. The shield surface reflects interference energy because the impedance discontinuity at the shield boundary. Shield also intercept radiated noise and return to its source through low impedance. A common way to reduce EMI is by shielding the cable to suppress the radiation from interfere with other electrical device. The condition for this protection to be effective is a good electrical connection between the metal shield enclosing the source of EMI and the mesh of a vehicle. But there are some drawbacks with this method. A shielded cable is more expensive, heavier, and more difficult to mount correctly than an unshielded cable. There is also a risk of damage of the shielding caused by vibration from the vehicle. Next is by put the LC filter and reactor at ignition system. Capacitors, inductors, and LC filters are used on the low voltage side. In order to reduce the level of radio EMI at a frequency of long wave and medium wave ratio, attach one capacitor in parallel to the source of EMI. While reactors are used to improve the effectiveness of suppression in the range of ultra-high frequency wave at 300 MHz to 3 GHz. The inclusion of a reactor in the power cord of an electrical equipment prevents EMI from the power supply. A low-pass filter can be built and form a standard resistor plug to suppress the radiation caused by the ignition system. The improved filter spark plug reduces the radiated EMI by an additional of 10 dB at 100 MHz and 20 dB at 500 MHz. However, there was very little EMI reduction in the 10 to 20 MHz frequency range.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Today I'll be presenting about competitor analysis and conclusion. Let's move on to competitor analysis. Here we choose 3 different car manufacturers to make comparison how they deal with the electromagnetic interference. The 3 car manufacturers is Tesla, BMW, and Nissan. Okay, here is the table of competitor analysis. As you can see, all of the 3 car manufacturers use fully electrical system and hybrid system. The solution that they came out to deal with the electromagnetic interference is filter in ignition system and shielded cable. And you can see here, all 3 of them use the same kind of method. But the difference is the way that they implement the solution shows that how creative and innovative skill and thinking they have in order to compete in their business market. Okay, here we have the EMC testing, which is done by the 3 car manufacturer, shows and prove that they successfully deal with the electromagnetic interference problem. And you can see here the price range is not in the height difference between 3 of them, but the critical part is where the spare part, which is for BMW is hard, and Tesla and Nissan is medium level. We know that BMW always hard, but not just hard, but also expensive. Okay, moving on to the conclusion. Okay, here we have the electromagnetic interference is a common problem in automotive world. In this research, we know that all car manufacturers also having the same problem. And the second is we know that how electromagnetic wave work and how it affect other system as they cause a disruption of electronic device makes them kind of dangerous for the automotive world. And the last one is we're able to identify the solution to deal with the electromagnetic interference in automotive vehicle as I present to you before. The three car manufacturer use the same solution, but they have a different kind of way to implement the solution, which make them uh, really creative and innovative in order to compete each other. That's all from me. Thank you.